Okay, the day has finally come. We are doing basic rules of derivatives. This is exciting for me, and I hope it's exciting for you as well. So we will do one part where we'll do some limits, and then we'll get into the rules. Okay, so learning outcomes: state the constant, constant multiple, and power rules. Apply the sum and difference rules to combine derivatives. Okay, so our constant rule essentially says this. There's a proof up above. If f of x equals some constant c, then the derivative is 0. And if you think about that conceptually, if we have the, see if I can get that to actually go to the color. Okay, if I have a line c, someplace c, f of x equals that line, then that's just a horizontal line. And so what's the slope of that line anywhere? The slope would be 0. So anyway, our derivative of a constant value or constant function is 0. And this d dx is another way of writing the same thing. It means the derivative with respect to x is the variable with respect to, in this case, of c equals 0. So what is the derivative of f of x equals 8? Well, f prime of x would be 0. Derivative is 0 because it's a constant. Same thing down here, g prime of x equals, again, 0, because g of x equals some constant value, which is -3 in this case. Now we get on to the power rule. So let's first think about taking our derivative, like d dx of x cubed, and this applies when we're doing derivatives of polynomials or a variable to a power. So power rule. So not necessarily a polynomial, but those are included. Now, this derivative could be seen as the limit as h goes to 0 of x cubed. Sorry, let me fix that. Should be x minus h cubed minus x cubed all over h. So we have the limit as h goes to 0 of x cubed. This is it's x plus h. I keep doing the minus lately. Plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h. And you see these x cubes are going to go away, as we have seen countless times. So we have the limit as h goes to 0 of 3x squared h plus 3xh squared plus h cubed all over h. If you divide the h out, you'll have the limit as h goes to 0 of 3x squared plus 3xh plus h squared. And that limit then, if you put a 0 in for h, is just going to be 3x squared. And it's the same process for this d dx of x to the fourth. Exactly the same process, you just have to know the expansion for an x plus h to the fourth. So again, we're looking at the limit as h goes to 0 of x plus h to the fourth power minus x cubed, or x to the fourth, excuse me, all over h. So that expansion is going to be limit as h goes to 0 of x to the fourth plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the fourth minus x to the fourth, all divided by h. And again, we're going to see these x to the fourths subtract out. Everything left has an h in it. So we have the limit as h goes to 0 of 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the fourth, all divided by h. So you divide an h out of everything. You have the limit as h goes to 0 of 4x cubed plus 6x squared h plus 4x h squared plus h cubed. And as h goes to 0, everything with an h is 0, so this becomes 4x cubed. So my question to you is, just looking at these, do you recognize a pattern between them? So notice that was an x cubed, and the derivative is 3x squared. This is next to the fourth, and the derivative is 4x cubed. And so if you're seeing it, great. If not, let's go down to the rule. This is called the power rule. And so what it's saying is, if you have f of x equals x to the n power, then the derivative is going to be, you bring that power down in front, and then you subtract 1 from the power. Or the derivative with respect to x of x to the n is n x to the n minus 1, subtracting 1 from the power. Here they're showing it in a generic case. So you can see it works generally. So here it says find the derivative of the function f of x equals x to the 10. Well, our f prime of x would be 10 to the x to the 10 minus 1, or 10 to x to the 9th, 10x to the 9th. Okay. I hope that's pretty straightforward. You're saying to me probably, oh my gosh, why? Why didn't you show this earlier? And the idea is that we really should understand how the limits work. Let's do this one. F prime of x is going to be 7x to the, and then subtract 1 from the power, 6. That's it. Now we have a couple of differentiation rules, and I think it's somewhat common sense on these. And the idea, if you take the derivative of a sum, it's the sum of the derivative. So what I'm trying to get at here is taking the derivative of the sum, you have the derivative of the first one plus the derivative of the second one. And this is showing the same notation. They're saying j, and so I don't know if it's j for joint or whatever, joint functions. F of x plus g of x, the derivative of j is the derivative of f of x plus the derivative of g of x. And then down here, for a difference, same thing, the derivative of a difference is the difference of each derivative. Same thing here, derivative, taking the difference of the derivatives. And then if you have a k being multiplied by, you can factor that k constant k out, and it's just the derivative, k times the derivative of the function. Okay, so let's look at, find the derivative of g of x equals 3x squared and compare it to the derivative of f of x equals x squared. So for g of x, or for g prime of x, that's just going to be 3 times the derivative with respect to x of x squared. So it's 3 times 2x, or it's 6x. And then for our f of x, the derivative is going to be just that 2x. So they both have the same power, but the one has the coefficient of 6. So like if we were graphing these, one would be really steep, and the other one wouldn't be quite as steep. Okay, let's do apply it now. So f of x equals 2x to the 5th plus 7. So our f prime of x is going to be 2 times the derivative of x to the 5th is 5x to the 4th, and the derivative of 7 is 0. So this is 10x to the 4th. And for this one, same type of thing, our f prime of x, so I'm going to have a 2, we can factor that 2 out, times, now the derivative of x cubed is going to be 3x squared, minus 6 times the derivative of x squared is 2x, and the derivative of 3 is 0. So our f prime of x is 6x squared minus 12x. So find the equation of the line tangent to the graph of f of x equals x squared minus 4x plus 6 at x equals 1. So the first thing is we need the point. We know x is 1. What's the y value? So y would be equal to f of 1. And that's 1 squared minus 4 times 1 plus 6. So that's going to be 1 minus 4 is negative 3 plus 6 is 3. So equals 3. So we have the point 1 comma 3. Now if we want to find the slope, we need f prime of x. So f prime of x equals 2x minus 4, because the derivative of x to the 1 power is just 1. Derivative of 6 is 0. So f prime at 1, that same x value 1, what's the slope going to be? It's 2 times 1 minus 4, which is negative 2. So we go y minus y1 equals m times x minus x1. So y minus, and our y1 is 3 equals m, which is negative 2, times x minus x1 is 1. So y minus 3 equals negative 2x plus 2. If I add 3 to both sides, y equals negative 2x plus 5. Okay. And what else do we have here? Another 2 problems. Find the equation of the tangent line to the graph of this. So again, we're going to look for our f of 2 to begin with to get the y value. So that's going to be 3 times 2 squared minus 11. So that's 2 squared is 4. 3 times 4 is 12. 12 minus 11 is 1. And we want to get f prime of x. It's just going to be derivative of 3x squared is 3 times 2x. Derivative of 11 is 0. So it's 6x. So f prime at 2 is 6 times 2. So we have y minus our y1 is, what is it? The points were 2 comma 1. Y minus 1 equals, I didn't write 12, yeah. Y minus 1 equals 12 times x minus 2. So y minus 1 equals 12x minus 24. Y equals 12x minus 25. Okay, now for our last problem here. It says if f of x equals 5 plus 2x minus 5x squared, what is f prime of 2? So our f prime of x is going to be 0 because the derivative of 5 is 0, plus 2, because the derivative of 2x is 2, minus 5 times 2x. So f prime of x, it's going to be 2 minus 10x. So f prime at 2 is going to be 2 minus 10 times 2, or 2 minus 20, or negative 18. And that's it. Okay. Hope this is a sigh of relief for most of you. It is for me. Okay. See you guys later. Bye.